Uh, so I'm just giving a very brief talk about what we're doing at MIDES. So this work was collaborator with the Pablo sit here and a professor at Sloan. And feel free just give any comments because it's ongoing work. The title was look like a little bit technique, but basically we're trying to set up a game for data center demand response based on the CPU utilization and quality of service, which I will explain later. So the first backgrounds we all know is data center express increasing in the energy assumptions. It is predict that data center power assumption is going to double or even triple worldwide. And in the same times, if we look at data center, what happened is the computation load is begin to increase in terms of the total energy consumption. That means the power usage effectiveness, so their power efficiency is improved gradually. So in terms of just trying to provide more efficient thermal or cooling solutions for data center and saving energy, this work is trying to investigate how to improve the efficiency through the computation load. If we look at the computation load, there's a very important matrix called CPU utilizations. You can actually see it from your computer. It's easy to visualize. Depends on how you're using the computer modules, and it's changing all the time with the different computation load. So if you look at this graph, this is from the screenshot from the common computer. You can see there is a spark and down throughout the time. That means you're doing different tasks, such as computing or just idle or leave your computer there. There is a lot of open source data for this CPU utilizations. So we take one from the Microsoft 2019 dataset, which record millions of virtual machines from the CPUs. So an interesting factor we can see from here is most of the time the CPU was idle. So you can see a majority of time CPU just utilization is below 20, which is normal because you can't switch off the computer modules. So basically a lot of computer just wait there and waiting for the upcoming jobs while consuming a lot of energy. So a very idea is how could we just utilize this data and trying to reschedule jobs or doing some things to make the computation efficiency even higher. Here I want to introduce a mechanism that you may not realize, but is existing or embedded in every computer or mobile phone. It's called dynamic voltage frequency scaling. So its modules was embedded in almost every CPU or GPU. The way it works is going to flatter your computation load based on the utilization. So you can see here it's a bar chart show how it's work. So before you have a high peak load, maybe you are just compute something, and when you don't compute it was P idle, so the power is just reduced. So the dynamic voltage frequency scaling is trying to shift a part of the high peak load to the idle load. So the overall peak load was lower, but then better use with the idle time. And the power saving from the DVFS can be modeled as the second orders functions in terms of the utilization. So, but however, you can do a more fine calculations, but roughly the blue shade area is what the power saving can produce because of the dynamic voltage frequency scaling mechanism. So here we set up a game says if we have a lot of computation module in the data center, they all conduct sort of dynamic voltage frequency scaling. How much power saving we can get from those data center? So basically, the procedure was we extract the CPU utilization readings from different computer, and then apply the DVS power saving modules and conduct a game, trying to model how the data center beating this service in the power market, and then we try out the out of sample test to see how reliable this service is. And here is a CPU power saving index we calculate just from the real data trace from the Microsoft data set. I will jump out this math because uh, then the rest of thing is how using the math to formulate the game. Let's jump to the results. So we try out from the data center 2 to the 100. So you can see because of a computation, marketing computations, the demand response offered by each data center is reduced when the number of the player in the power market increase. That is because when you offer more demand side response or demand service, then the price of the per unit demand response will reduce. Therefore, the data center offer less. The per data center offer less demand response in this case. And here is more results. We calculate the price based on the different number of data center, and the QoS losses you can understand as the losses because you delay some job. Remember in the first chart, like the DVS, how it works is shift the part of load to the idle time. So if you do that, there is a trade-off between the work you want to do it now, but you shift to later. So there is a trade-off the work qualities. So you can see the quality of service cost for a data center. It's changed throughout the marketing price. So this is a ongoing work. I hope you find it interesting, and if you have any comments or any thoughts, feel free just contact me. Yeah, thank you.